Okay, let's dive straight into it and let's go make it maths. And yeah, so last time what we're doing is we had our circle centered at the origin, but this time what we're going to do is say, well, what happens if we've got a circle that's, say, sitting like that? Great circle again. And it centers over here, not at the origin. Then we'll say, well, we've got this point here as 2 and 1. And this one's got a radius of 5. And we need to describe that circle now. So we can't use x squared plus y squared equals r squared. I'm just going to put that x squared plus y squared equals r squared. That was for when it was centered at the origin. But now things have moved around. And let's just kind of tap into how we're going to, like why our formula is going to come from. So here we go. Let's draw our beloved right angle triangle, right? That's how we looked at things to start with. We've got a right angle triangle. And this length here, well, we'd kind of need that point to know what that length is. So to take this, I'm going to pause on that one there. I'm going to take that, copy it, just so it's still there. And so keep drawing on your one and remove that out the way and say, okay, so let's say that I give you a point on the circle. I'm going to ask you, is this point 6, 4? Is it on the circle? And we're just exploring here. So it's not just, perfectly describe is that on, but this is going to help us explore and get to grips with what's going on. So let's see, if it's on the circle, then that squared plus that squared equals 5 squared. So let's look at our lengths. So this length here, what's the length of this bottom part of our triangle? Well, if that's 2 and that's 6, this length must be 4. Now, what's this length over here, this height of this triangle? Well, that's 1 and that's 4, so that's 3. Kind of see where we're going with this, right? Because, again, we got this idea of, well, we got our 4 squared plus 3 squared. Well, that does indeed equal 5 squared. In other words, this triangle kind of works out. Pythagoras works. We got 4 squared, 3 squared. So that seems good. Now, the question is, how did we get that 4? How did you know that that length of the base of our triangle was 4? Well, could be multiple ways of explaining or describing this. The way that I kind of think about it is to go, well, I took this 6 minus 2 to give me 4. So that was 6 minus 2 gave me that 4. So similarly for the 3, would have gone, 4 minus 1 gives you 3. Because you got, this point's y value is 4, this one is 1. So clearly this distance here must be 3 because you went 4 minus 1. Okay, and that gave us our 5 squared. So here's kind of my equation where we went, that squared plus 4 minus 1 squared equals 5 squared, which is our radius squared. Now this should work for any point on our circle, right? Shouldn't matter where we are. Anywhere, going to kind of get the same idea. You're going to find this distance, that squared plus that squared equals r squared. Now that means that any x value, if we subtract 2 from it, we'll get that length squared plus any y value and we subtract 1, we should always get the radius squared, and the radius in this case was 5. So there's our equation. So what our equation looks like in general terms is if we subtract the center point, we're going to get the radius squared. Now, that was put badly. Let's draw another clean circle here. And in fact, I'm just going to jump up here and go, just pause, take that in. Okay, so we've taken that in a little bit, and we're going, well, let's take a circle. Let's center it anywhere over here. Doesn't matter where on the Cartesian plane. I happen to have put this one in the first quadrant. And it's got a center with coordinates A, B. In the example previously, we had 2, 1. So if that's the center AB, and it's got a radius of something, then our general formula is going to be x minus a squared plus y minus b squared equals r squared. So quite similar to our one at the origin, but this time you've got x minus a squared y minus b squared, where the center of our circle is at a, b. Okay, so that's our general formula. Now, the only thing to kind of maybe make reference to here before we do a couple of examples is, do you remember when we did the parabola? So parabola, you started with y equals x squared, and then at some stage you went, but what happens if we move this graph left and right? You went, oh, y equals x minus p squared. Remember that idea of moving it left and right? You had subtracted this p. So maybe you think of that in the same terms of, well, if you move it left and right, you've got this a, and if you move it up and down, you've got this b. You do the same with the y part. So that's just, think about a parabola moving around. Okay, that's kind of explaining where our formula comes from. Of course, from here on in, you're probably just going to think, oh, that's what our formula is. So let's take two examples. And let's say I give you a circle and I give it, I tell you this about this circle. It's got a center over here. There's our beautiful circle. They get better every time, don't they? No. Okay. So this center is at -3 and 5. And the radius of our beloved circle here, which is the same all the way around, as you can see from the diagram, right? Our radius here is 7. So the question is, what's the equation of that circle? Well, remember our general formula was x minus a squared plus y minus b squared equals r squared, where a and b are the center, or the x and y values respectively of the center. So in this case, we got x minus a squared plus y minus b squared equals, well, r squared is easy, that's 49. Now x minus, well, we've got to go minus 3. So minus 3 will make it plus 3. Y minus this value, that's 5, so y minus 5 squared, and there's the equation of our circle. Okay, so that's it for if it's on the center. As I said, for now you're just going to use that, but maybe interesting enough to see maybe where they came from. That idea of Pythagoras always coming up. So there we go. There's an exercise on the website to do. They're very, very quick to do. It shouldn't take you too long. Should finish in this lesson still. Pop back on, have a chat if you need to. And of course, you know what you need to do. You need to make it maths. Right. Okay, well, enjoy. Goodbye.